Welcome back to Chapter 2. We're looking now at graphs, and in particular we're going to look at two different types, and that's a histogram and a bar graph. And they're very similar, as you'll see when we make them. The histogram you will use with continuous data. You can think of it anything that has boundaries. If you have boundaries, you should probably be using a histogram. A bar graph is for discrete values or qualitative data. A qualitative data set should always be a bar graph as opposed to a histogram. So that's just kind of a heads up on when you're asked to do one particular type or another, which one to choose. So looking at a couple of examples here. First of all, we're going to take that example that we did before with the speed. I have a frequency table rather than a relative frequency table, and we're going to make, in this case, a histogram because it's continuous data. So that would be our choice in this case. Every graph, just like every table, has to have a title. And once again, this title would be speed. You need two axes for this, an X and a Y axis. I use a little drawing tool here to get straight lines. You'll obviously be doing this with a pencil, so that won't be the case. Now, notice the largest value here is an 11, so I want to make sure that my highest value includes at least that. And I would probably myself go in steps of 2, 2, 4, 6, 8, 10, and then 12. 12 covers enough, and they're nice values. The speed down here on the bottom, since it is a histogram, you should be using your boundary values. 20.5, 27.5, 34.5, 41.5, 48.5, and then our last one, 55.5. Then it will look like a bar graph. Many of you are actually familiar with a bar graph, the only difference being a histogram, that first class having 8, the next class having 3. A histogram actually is side-by-side bars. They touch one another. This next class goes up to an 11. The next one to a 7. And then the very last one to a 4. So those are not going to be perfectly drawn by hand, but you should have them relatively close. Make sure that when you're using continuous data, that you are using a histogram rather than a bar graph, that you make those touch, that the edge of your classes are in fact the boundaries themselves, not the class sizes, not the 21 and then the 28, but the actual boundary values. Next, we'll look at a case here that these are qualitative data. And with qualitative, we will want to use a bar graph. And again, needs a title, in this case, colors. And again, axis. Highest value of 6. I am again going to go by 2, so 2, 4, 6. I'm even going to go on up to the 8. Could have gone 1, 2, 3, 4, 5, 6. That's optional. My colors are red, blue, green, and then yellow. The difference now is with a bar graph, they don't touch. So this red, there are 5 red. And then there are 6 blue. Four green. And lastly then 3 yellows. So that you can see that the bars are definitely separated. That's really the only difference between a bar graph and a histogram, is the separation of the data. Or excuse me, the separation of the bars. And it's dependent on the type of data. Qualitative, definitely the bar. With quantitative, depends on whether it's discrete or continuous.